Namaste, this is Maudya, studying in Shri Venkateshwara College of Engineering, 6th sem from the Department of Computer Science and Artificial Intelligence. Today I'm going to present about the topic Support Vector Machine, SVM, and its kernel type, which comes under the subject Machine Learning. So what is a support vector machine? A support vector machine, it is a supervised machine learning algorithm. Supervised machine learning algorithm, it is nothing but the algorithm, it uses a labeled data set to train a algorithm which predicts the outcomes. So it is commonly used for classification and regression tasks. Here are the key components and the concept of support vectors machine. Those are hyperplane, support vector and margin. In the hyperplane, a decision boundary that separates different classes in a feature space in two dimension. That is, it is a line. In three dimension, it is a plane. In higher dimension, it is hyperplane. Here you can see a special feature, that is a two dimension means it's a line. Three dimension, it refers to a plane, and in higher dimensions we refer to it as a hyperplane. Next comes a support vector, the data point closest to the hyperplane and the most critical in defining the position and orientation of the hyperplane. These points are used to maximize the margins between the two classes. What are margins? The distance between the hyperplane and the nearest data point from either class. This SVM, it aims to maximize and improve the model's generalization ability. So how does this support vector machine works? SVM finds a hyperplane that maximizes the margin between the two classes. The margin is the distance between the hyperplane and the nearest data point from each class. We discussed this in the previous slide. And in the support vector, how the SVM works. The support vectors are the data points closer to the hyperplane in the decision boundary. The decision boundary is determined by these support vector. And to maximize the margin, maximizing the margin helps to achieve the better generalization and reduce the risk of overfitting. SVM optimization. The objective of the SVM optimization is that the primary objective is to maximize the margin, which is the distance between the hyperplane and the support vector. The quadratic programming. SVM uses the quadratic programming to solve the optimization problem. The mathematical approach helps in finding the optimal hyperplane that maximize the margin. The regularization of parameters. Regularization parameters are the controls the trade-off between maximizing the margin and minimizing the classification errors. A small regularization parameter value encourages a wider margin but allows some misclassification, promoting generalization. If the regularization parameter C is larger value, it aims for fewer classification, which might lead to a narrow margin and potential overfitting. So moving on to the types of kernel, we have linear kernel. Let us see the equation of the linear kernel. That is k. That is k x comma y is equal to x into y, k of x comma y, which is equal to x divided by c dot y, k x comma y is equal to x into y. What are the characteristics of this linear kernel? It is suitable for linearly separable data, simple and compensate efficient. What are the use cases of this linear kernel? It is text classification and the image recognition. These are the use cases of the linear kernel. Moving on to the polynomial kernel, here you can see the equation kx comma y is equal to yx into y plus r into d kernel x comma y is equal to gamma x slash c dot y plus r into d. Kernel of x comma y is equal to yx into y plus r into d. Now the characteristics of this polynomial kernel: map input space to higher dimensional polynomial space, and to capture the interaction up to the degree odd. The use cases are the natural language processing and the complex image transformation. Next comes the radial basis functional kernel. So here you can see the equation of this radial basis functional kernel. The characteristics are suitable for nonlinear data mapped to an infinite dimensional space. The use cases are image classification and bioinformatics. Next, moving on to the sigmoid kernel. Here you can see the equation of the sigmoid kernel. The characteristics are similar to the neural network activation functions, and it can capture the complex relationships. Here the use cases of the sigmoid kernel, that is a neural network based data analysis and the pattern recognition. These are the types of kernels, and the equation, characteristics and the use cases we have discussed. SVM in practice: how to use the support vector machine accurately. Choosing the right kernel is important. Selecting the appropriate kernel function is crucial for achieving the output. The choice depends on the nature of the data and the specific problem at hand. Next, the hyperparameter tuning. Tuning parameters such as regularization parameter and the kernel specific parameter can significantly improve the model's performance. Proper tuning helps balance the trade-off between the margin maximization and the classification accuracy. Next comes the cross-validation. The cross-validation is essential for evaluating the model performance. It helps in selecting the best parameters and kernel by providing an estimate of how the model generalized to an independent data set. Common techniques include k-fold, cross-validation and the grid search. Next, the practical steps. Start with the simple kernel, such as a linear kernel, and move to the more complex ones. Use the grid search or randomized search for hyperparameter tuning. Validate the model using the cross validation to ensure its performance well on unseen data. So here are the applications of support vector machine. Those are image and handwriting recognition. SVM is widely used in computer vision tasks, effective in recognizing the pattern in images and the handwritten digits. For example, digital classification in MNIST dataset. Next comes the text categorization and sentiment analysis. SVM can classify documents into different categories based on their content, useful in natural language processing and sentimental analysis. For example, classifying the customer's review as positive and negative. So it will be helpful for future decisions. Next, in the bioinformatics, protein classification, SVM helps in classifying proteins based on their amino acid sequence. Next, even in the cancer detection, used to identify the cancerous cell in the medical images and the data sets. For example, classifying the tissue samples as malignant and benign. Financial time series forecasting. SVM is applied to predict the stock prices and financial trends, helps in analyzing and forecasting the time series data. For example, we can predict the stock market movements based on the historic data. So in this presentation, we have covered the concept of SVM efficiency and the kernel selection, practical applications, optimization and tuning, application of kernel, application of SVM, and the future directions of SVM. And it continued advancement in the kernel methods and optimization techniques are enhancing the SVM capabilities. Integration with deep learning and the other AI techniques could further expand its application. Thank you. Please do like the video.